Live from our hurricane headquarters with real-time analysis from some of the nation's top meteorologists, this is Tracking the Tropics, powered by Bose Electric.
As Hurricane Lee churns in the Atlantic, the peak of hurricane season is here, and with it, we have a special episode of Tracking the Tropics with head hurricane researcher at Colorado State University, Dr. Phil Klotzbach, ready to answer our questions and yours here on Tracking the Tropics from the Stream Center in Tampa, Florida. Hello there to you folks. We have quite the panel joining us here on this Wednesday edition of Tracking the Tropics. Not only are the tropics highly active, but we have Dr. Phil Klotzbach, the head hurricane researcher at Colorado State University there in the bottom right-hand portion of your screen, on standby to answer your questions. And yes, we're going to use Dr. Phil, hashtag Dr. Phil, as far as interactively how we're going to answer your questions today. Of course, we have meteorologist Rebecca Barry, chief meteorologist Jeff Baradelli, but we're going to start things off here with Amanda Holly to break down exactly what we're looking at here, Amanda, in a very busy tropics.
Yeah, we are coming off the heels of peak hurricane season, just 3 days after peak hurricane season, and it looks like it out there. We have Hurricane Lee, of course, Hurricane Margot churning in the central Atlantic, another wave we're watching with a high chance of developing. So we are talking about a busy Atlantic with really no signs of it stopping just yet. But we'll focus in on Hurricane Lee first. Right now, it does look pretty good on satellite. We're still talking about that major Category 3 hurricane strength. It looks like it has a symmetric structure here. Looks like we might see some dry air kind of near the eye, but overall, the hurricane hunters still flying in and out of the storm to get an idea of the strength of the storm. Regardless, we do think that it is actually going to weaken as we go through the next couple of days. It is going to pass just to the west of Bermuda. That's that little island there. And the orange shading are tropical storm watches and warnings in effect because they will be on the fringes of Lee because it is so large. So they'll still feel impacts from Lee for sure. It's just not going to make a direct landfall there. But you can see how it is expected to weaken to a Category 2 hurricane tomorrow, and then a Category 1 storm by Friday, staying there but slowly weakening as it moves off toward the northeast, toward Nova Scotia. So we are talking about possible land impacts with Lee as early as Saturday morning, lasting through the weekend. So we are going to talk about some of those impacts in depth here over the next several minutes. But overall, that is the forecast track. You can see we do have a pretty good agreement on where this is going with those forecast models. I mean, really good agreement all the way up until Saturday morning. Then there's a little bit of spread with those forecast models. And again, as we always say, a 20-mile shift east or west is going to make a big difference in impacts on where this is going to go. Now, we're likely going to see those strong winds up and down the northeast coast here because of the large size of Lee. But the storm surge impacts are going to be in question on exactly where that eye comes ashore. But right now, it does look like we are going to see land impacts with Lee, regardless of where it makes landfall. Some sort of land impacts are expected this weekend. GFS, Euro, everybody likes to look at it. They're also in really good agreement. I will say the GFS, the green bubble here, little bit faster than the European model. However, they basically follow each other. The GFS is just making landfall a little bit earlier, sometime early Saturday morning, Saturday afternoon, and that would come with then the European models right behind it, but generally in that same area. So we are going to keep a close eye on that. But why is Lee going to weaken? Well, we have to look at the available ocean energy because we know that those sea surface temperatures provide the fuel for the hurricanes to maintain their strength. And look at the past track of Lee here. Yeah, you see where the ocean heat energy actually breaks apart. That's because Lee used up that ocean energy to maintain that Category 3, 4, and 5 strength while it did. It's been lingering in this area a little longer, so it's used up a little bit more energy. But as we go forward in time, it's actually going to move into an area with less available energy, lower sea surface temperatures. So we are talking about it likely weakening as it moves past Bermuda, continues off to the north, and really enters those cooler surface temperatures up along the northeast. They're still above average, but generally too cool to maintain that tropical strength, so it will likely continue to weaken. The one major impact the entire East Coast is going to experience are significant wave heights. We're already seeing swells from Lee reach the east coast of Florida. And those swells are going to be felt up and down the east coast, leading to very strong rip currents. So that is something we're going to really continue to watch through the end of the week. Obviously, as you get closer to the storm, you're talking about those much higher wave heights, 30 to 40 feet, if not even higher than that, as it passes off near Bermuda. It is going to maintain some of those wave heights as it approaches the northeast. So this is kind of what we're concerned about as we go into the weekend. Yes, the wind speeds, but we're not talking about a major hurricane making landfall up along the northeast, but we are talking about some significant wave heights moving toward that northeast coastline, including the Nova Scotia area as well. One thing right now, wherever it comes ashore and to the west of it, we are going to see that offshore wind, which will help the storm surge. But you got to really pay attention to the wind direction, because the Cape Cod Bay here, yeah, we are going to have those onshore winds pushing a lot of water in that region. But wherever it comes ashore, we really have to watch for those onshore winds. That's where those winds are going to push that water up onto the coastline, something we're going to continue to narrow down over the next few days. But in general, again, the tropics very busy. This is Lee. We do have Margot out here. It is still a Category 1 hurricane, going to kind of meander in the central Atlantic, what we call a fish storm for the next several days, the storms that we like to see. And then this is Invest 97L. It looks like it's going to follow somewhat in Lee's footsteps. Right now, I don't think it's going to be a concern to the Tampa Bay area, but of course we are going to continue to watch it for any of those East Coast impacts. It does look like it'll keep some of those swells along the East Coast for now. But I'll send it back to you, JB, as we continue this conversation and really get Dr. Klotzbach into our conversation.
Yeah, Dr. Klotzbach, I know that you have so much to share as far as your analysis on what we have seen thus far this hurricane season. Before I send things over to Jeff, Rebecca, and Amanda, want to let our audience know you can use any of the hashtags on your screen, including hashtag Dr. Phil, hashtag HeyJB, Rebecca, Jeff, Amanda, any of those hashtags, and we'll start to take your comments out of the Facebook Live comment section and bring them into our interactive conversation. But let's send things over to Jeff. Hey there, Jeff.
Hey, thank you, JB. And hey, Dr. Phil, I'm so glad to see you again. Thank you for joining us.
Yeah, thanks so much for having me. It's a good week to be on the show.
For sure. And I got to tell you, we never have this many meteorologists. We never have JB hosting the show with 3 meteorologists at the same time. So I got to tell you, we were all very excited to have you. Just to let you know that this is a rarity. We all wanted a piece of Dr. Phil.
Well, this would be a good geek out session. Looking forward to it.
All right. So my first geek question, what I've been geeking out about is, the track has shifted a little bit west over the past couple of days. And it almost looks like it's possible this could come ashore in extreme down East Maine or right over the Bay of Fundy. Now, I know we talked about this briefly pre-show, but the Bay of Fundy has the largest tidal range in the world, something like 45 feet. I mean, if nothing else, first of all, it could be incredibly dangerous to be near the Bay of Fundy during this storm, potentially, depending on where it goes. But also, this could be a tremendous science experiment to see what happens when you force storm surge into something like the Bay of Fundy.
Yeah, definitely. I mean, I think there's certainly going to be at least some storm surge up into there. It's as was already mentioned, it depends exactly how the storm tracks and everything as to how much surge gets up in there. It's also going to be at about the time of a new moon, so that tends to add a little bit of additional range to that tide as well. So yeah, there's certainly going to be some storm surge problems there. I mean, I think really I was glad to see the emphasis on the wave action. I grew up in Plymouth, Massachusetts, like 3 miles from the water. So I've seen a lot of that firsthand. There's going to be a lot. The storm is going to be moving for a northeast storm fairly slowly. So, as you see this graphic, it's great, kind of highlights just, you're going to have a lot of wave action just pounding that shoreline. And obviously growing up in southeastern Massachusetts, there's a lot of coastal erosion issues already. So this is certainly not going to help with those. So yeah, as was mentioned earlier, obviously, we always talk about the wind with hurricanes, but I think in this case, the wind is going to be an issue, but the wave action and potentially some storm surge, and also rainfall. Southern New England's just had a ton of rain. And if you look at the stream gauges, a lot of them are running 5, 6, 7 times what they normally do. So there's likely to be some river and stream flooding as well as also if the ground is saturated. And we do happen to get, especially places like the Outer Cape that may be closer to the core of the strong winds, if you have the ground is saturated, it's more likely these trees are potentially you get some tree damage as well. Hopefully not like what we saw, say, in a storm like Hurricane Bob in '91, but we still could see some trees go down as well. So, if we were to get those Euro forecasts of 2-4+ inches of rain, they had a ton of rain on Monday, especially in central New England. They're going to get a lot more rain today, and then obviously when Lee comes ashore. So there's definitely some concerns with this storm. Even though, as Amanda mentioned earlier, the storm is likely to weaken as it tracks over cooler water and also gets sheared by this upper level system that's coming through. You're kind of already starting to see that on satellite, but that shear is likely to get quite a bit stronger. So, but because the storm is so large, it's going to take a long time to kind of spin that sucker down. So even with the shear and colder water, it may actually structurally look more like a mid-latitude system, might undergo extratropical transition, but it's still going to have very significant impacts. Right now, the hurricane force winds extend over 100 miles away from the center of the storm. So from a wind perspective, a small change in the track won't necessarily matter a ton. Obviously, it'll matter more for things like surge, but for just the overall wind impacts, a large area is going to see tropical storm force winds, gale force winds, and maybe even some hurricane force winds, especially in places like the Outer Cape.
Mm-hmm. I think Rebecca's next.
Absolutely. And so I was watching it on satellite. I know we'll get an update when the 5 o'clock update comes out, and they are predicting it weakens. I was trying to decide on the satellite if it was going through an eyewall replacement cycle right now, or if that drier air was just starting to erode the system and it's going to be much weaker than we actually thought it would. And so do you guys think this is still a Category 3 storm right now, or do you think it's already down to a 2?
Well, they're currently flying it. So we'll see what the recon says on that. There's definitely some dry air starting to kind of get eroded in or being brought in, but it does actually look like it's mixing it out fairly efficiently at this time. So we'll see what they find in there. One metric that we like to look at a lot is the pressure of the central pressure of the storm, and that's been remarkably stable. And when your storms gain latitude, often the central winds will weaken, but the storm will also grow in size. And so pressure is when you have low pressure in the center of the storm, you have high pressure outside of it. The winds operate off of that gradient in pressure. So if your pressure stays the same and your storm grows in size, the gradient is spread out over a large area. So the winds at the center of the storm will come down, but the radii of the strong winds will actually expand. So from an impact perspective, a large weaker hurricane versus a small stronger hurricane in terms of maximum winds. I mean, it depends on where you are relative to the storm, but potentially a larger storm can even have greater impacts, especially if you're not located right in the core of the system.
For those just joining the live stream, here we are in the Stream Center in Tampa, Florida with special guest Dr. Phil Klotzbach of Colorado State University. You can use any of our hashtags on screen to ask Dr. Phil Klotzbach a question. Let's go to the first questions that are coming in. Again, use a hashtag, ask a question. This is an interactive broadcast here across our platforms on social media. And it starts here with Justin Cruising. I have another one behind this that I'm going to try to get to in here. But this one comes in, and this is a big question as far as hurricane season. Do we still expect a busy season? This is something that is right up your alley, Dr. Klotzbach.
Yeah, I mean, we've already had quite a busy season so far. We're trending about 150 to 200% of normal, depending on which number that you look at. So an average season has 14 storms, 7 hurricanes, and 3 major hurricanes. So we've already had an average season in terms of named storms and major hurricanes. There's this geeky metric that we love to use, accumulated cyclone energy. That accounts for storm frequency, intensity, and duration. So a storm like Lee that's out there for a long time and is a powerful storm generates a lot of this ACE. And so that index is already up to about 70-80% of normal. So yes, the season has been busy. Even if the season ended today, by NOAA's definition, it would be considered an average season. And we're likely to be pushing the above average season definition, which is based on that kind of geeky ACE metric after this current invest that Amanda noted earlier. That looks like it's probably also fairly likely to become a hurricane as it tracks northwest, but hopefully no significant land impacts. But yeah, I mean, it's been a busy season, likely to continue to be a busy season. That's was forecast by us at CSU, by NOAA, and by a lot of other groups. But it is surprising given we do have we're moderate to strong El Nino right now, which normally knocks down your storms. But because the Atlantic is so warm, it seems to be counteracting that and actually kind of winning the battle. We kind of highlighted that at the start of the season. We said it's basically a battle between an extremely warm Atlantic, record warm Atlantic, and a moderate to strong El Nino. And we really weren't sure which was going to win. We stressed the uncertainty. NOAA stressed the uncertainty. All these other groups that do seasonal forecasts similarly stress the uncertainty, but it seems like, at least for now, the warm Atlantic is winning. And as I mentioned earlier, all indications are that we at least have one storm that looks quite likely to form, and then potentially some other stuff behind it that's a little less certain, but that's obviously things get less certain as you move further out in time in terms of seeing what's going to form and what's not.
To re-emphasize, our audience might be thinking this, but I want to just hammer this home. People who watch our preseason editions of Tracking the Tropics and they see the NOAA season forecast and the Colorado State University forecast. That's, of course, coming from Dr. Phil Klotzbach and team. Let's get in this one more question that's coming in. We can answer this one really quickly, Amanda and team. Robin wants to know, okay, Cape Cod, watching from Cape Cod, the mid-Cape Bay side. Have we seen any watches come in, Amanda, for that area just yet? Or
we were just kind of discussing that prior to the stream. No storm surge watches and warnings are in effect just yet, but they should be coming out within the next 24 hours because of those significant wave heights that we are expecting to move up along the northeast coastline and into the Nova Scotia area. So they're not up just yet, but you should be preparing for that if you live along the coast, or especially in Cape Cod Bay, because even though you're going to be on the most likely the western side, it does look like the circulation around Lee will lead to some of that water push into Cape Cod Bay.
All right. I think, Amanda, you're up with the next question for Dr. Klotzbach.
Yeah, so I guess my question for you is about Lee specifically, and compared to the past hurricanes that you've seen, was it surprising how fast Lee intensified into that strong Category 5 storm, or not so much because of the available ocean heat content that was there when it did so? But I mean, it obviously went through a very rapid intensification process.
Yeah, I mean, Lee was a fascinating storm because it blew up quickly and then weakened really quickly too. And I think, the models and the Hurricane Center are all getting better at forecasting these rapid intensification events. We certainly saw the forecast was for it to rapidly intensify, maybe not quite as fast as it did. But then I think really kind of what surprised me even more was just how fast Lee then weakened. It weakened actually down to a Category 2 hurricane before re-strengthening a bit. And so that was some southwesterly shear that really wasn't anticipated to be as strong as it was. So I think, there's still real challenges with forecasting. In the case of Lee, I mean, the waters that it tracked over are 1 to 2 degrees Celsius, say 2 to 3.5, 4 degrees Fahrenheit warmer than normal, which doesn't necessarily seem like much to people living in the middle latitudes. But when you're in the tropics, a small 1 or 2 degrees Celsius temperature change makes a big difference in how the atmosphere responds. And basically, areas where the water temperatures, it's effectively rocket fuel for these storms. So you need to have other things besides warm waters. You need to have low levels of vertical wind shear, which I'm sure they talk about a lot on this show. Basically, that's a change in wind speed and direction with height in the atmosphere. Too much of that shear tends to tilt the hurricane circulation, disrupt it, and also tends to encourage mixing in of dry air, like we seem to be seeing a little bit with Hurricane Lee right now. But yeah, the fact the Atlantic is so warm, I think, has really helped Lee rapidly intensify. It's helping Lee sustain itself. But now Lee is actually kind of it's weakening due to a couple of, so basically Lee is really large. So the winds to the north of it are very strong, so it's causing a lot of mixing and churning up of the ocean surface, bringing up cooler water. But also, it's also tracking over the path of both Franklin and Idalia, which also cause a lot of mixing and cooling. So if we look at water temperature anomalies or differences from average right now, it's pretty much the entire Atlantic is bright red, meaning really hot, except for where those storms tracked. And we're going to see even more of that cooling once Lee goes over it. We'll see if the next system tracks over that same area. But yeah, basically, that's the one area right now where the water temperatures are not warmer than normal. And so basically, we call these like cold wakes. And so storms, when they're really big, will generate their own cold wake, but it's also tracking over the cold wake from previous storms. So these storms do impact each other as well.
All right, so I want to ask you a question. I want to go back to something you were talking about, which is the fact that there's this competition between El Nino and the record warm Atlantic. You were mentioning in a tweet the other day that wind shear has been very low, especially in the Caribbean and in that box that you drew. And you believe it to be a consequence of a very warm Atlantic Ocean. So essentially, El Nino should produce all this wind shear, but yet it's not. It's being counteracted by the Atlantic. So I'm curious, from a meteorological perspective, what is going on here? Why is a warm Atlantic mitigating wind shear from El Nino?
Yeah, and so, normally in an El Nino event, you get warmer water in the eastern and central tropical Pacific. And that tends to lead, basically shifts where your thunderstorms form in the Pacific Ocean from over by Indonesia more towards the Central Pacific. And as a result of where those thunderstorms shift, you get upward motion in those thunderstorms. Air goes up or goes in at low levels. Dr. Gray, my mentor, used to always say you have in or low level wind. Oops, sorry, I forgot to shut my phone off. You think I'd learned that by now? You have low level flow into those storms, air going up in the storms, and air diverging in upper levels. And so you get upper level westerly winds that increase the vertical wind shear in the Atlantic. However, a lot of that is due to basically temperature gradients. So in an El Nino year, normally the eastern and central tropical Pacific is much warmer, and the Atlantic doesn't really change temperature wise. And so when you have a warmer atmosphere, that tends to basically increase the heights in the atmosphere. So you basically end up with higher heights in the Pacific, and that also tends to increase the shear, whereas the Atlantic is also extremely warm. So that gradient or difference in temperature is a lot weaker than it normally is. So you're not seeing that overall shear response. And so, yeah, I posted a tweet the other day basically highlighting, or I guess a post these days since it's no longer Twitter, but basically highlighting how far off the normal curve we are. Normally, the warmer the waters in the tropical eastern and central Pacific, the more the shear. This year, our shear is quite a bit below average, not record low, but much lower than what you would expect, given the moderate to potentially borderline strong El Nino that we're currently in. And so, yeah, I mean, basically, this is what's likely led to a busier season than you would normally anticipate with an El Nino. And I mean, we've already kind of we're chugging through the names pretty quickly. My French namesake Philippe will probably get 2 this year. We'll see how much further we get down this list. But yeah, we're already to 14 storms, including the subtropical storm that's mentioned on this graphic that formed back in January. But we've obviously also had 3 Category 4 or 5 hurricanes already this year, which Lee reached Category 5 strength on September 7th, and that we had only had 3 Category 4 or 5 hurricanes by September 7th in 3 other years. 1933, which was an extremely busy hurricane season. We actually had 2 landfalling major hurricanes less than a day apart that year, as well as 2004 and 2005, which especially for people living in the Southeast U.S. and Florida, remember very, very well, 2 extremely busy years. So we're kind of in uncharted territory, and it looks very likely that we're going to end up with an above normal season by NOAA's definition, despite a moderate to likely strong El Nino by the time we look at like the August to October average, which is kind of what we usually use to classify the season, since August to October is about 85-90% of your storm activity.
And then I have a question for you. I was actually talking to Amanda about this earlier this week. When I started 20 years ago, spaghetti forecast models actually looked like spaghetti. There wasn't a big consensus. You really didn't have a good idea. And especially this season, we've had really strong model consensus. So the science has come so far. My question to you is, if you had an unlimited budget and no otherwise constraints, what would your project be? What would be the next really cool thing in the field of forecasting that you would work on?
Well, yeah, I mean, so the tracks of the storms have gotten quite a bit better. If you look at the same plots for Lee, thankfully the confidence is extremely high. There's a little bit of spread, but not a ton. Whereas if you say look at a storm like Margot, it's more like what we call a squash spider, where anything's kind of on the table, and that's just because kind of what's steering that storm is a lot less certain than what's steering Lee. Kind of one of the big questions with Lee is there looks to be some high pressure building in over, say, like Newfoundland, and kind of how strong that high pressure is how much further that storm goes west. Normally, kind of one of the things I look at when I'm looking at potential for Northeast U.S. Atlantic province of Canada landfall is, do you have high pressure in the days leading up to it up over the Atlantic provinces, because that prevents recurvature. Normally, your Bermuda High allows your basically storms track south of the Bermuda High. They get to the western edge of that Bermuda High, turn north, and go out to sea. That's kind of like your poster child perfect storm. It doesn't thankfully impact people, but obviously in this case, the high is a little bit further west, and you have this trough that's basically steering it north. But in terms of getting back to your question, I mean, I think we still need to focus a lot on intensification. If we were doing this 10 years ago, I would have said, the track forecasts are getting better, but we haven't made a lot of progress on intensity change. But we actually have in the last 10 years. Even the intensification process has gotten a lot better. Better model physics, higher resolution models has really helped. But there still is a lot of uncertainty. Frankly, for me, because I follow individual storms, but I look a lot more at forecasts for what's coming down the pike. I think Genesis is still a real challenge. sometimes models are in really good agreement, like for this particular system in the eastern central tropical Atlantic that has an 80% chance. Pretty much every model develops it. It's got very strong consensus, and this is probably going to go. But there are cases where you'll see every model develop a storm and it doesn't form, or other times where the models will not develop a storm and you end up with a major hurricane out of it. So I think genesis is a real challenging problem. I'd love to spend more research and effort on that. I mean, and I also, I'm a huge advocate for aircraft reconnaissance. I would love to see more aircraft reconnaissance. The Atlantic is great, but I'd love to see some more in other basins as well. But yeah, I mean, I think there's a lot of, we've made a lot of progress, but there's still challenges and things that we need to work on, especially when storms are tracking parallel to a coastline. Very subtle changes in the track can cause big differences in the impacts. And we saw that, for example, last year with Hurricane Ian, which happened to be basically the kind of the synoptic pattern, or what the steering currents, or basically the highs and lows that steered the storm, were just, there was a lot of different things going on. And so the models were all over the place with that storm. And, you know, in that case, when the storm's tracking parallel to a coastline, 20, 30, 40 mile difference in where the storm makes landfall makes huge differences on who gets impacted. For example, we saw in Ian, you know, obviously 12, 15 feet of storm surge in Southwest Florida, whereas Tampa, since it was on the north side of the storm, actually had a negative surge. The water was driven out of the bay. So there still is need to work in both track as well as intensity forecasting, especially these rapid intensification events, as well as rapid weakening like we saw with Lee.
Now, I'm the only person on this stream who isn't a brilliant meteorologist, so I'm just going to ask the question, what is genesis? For our viewers, they don't know what genesis is, so can someone explain that?
Yeah, it's just the making of the storm.
Sure, genesis. Oh, go ahead.
Yeah. You can explain it too, Dr. Phil.
Yeah. I was gonna say it's a great rock band. If you haven't checked them out, but also, I guess I'm dating myself a little bit.
Yes, you are. That's the '80s. Phil Collins.
Yes.
I'm a fan.
But also, yeah, basically Genesis is where a storm, so the National Hurricane Center puts out these tropical weather outlooks 4 times a day, where they basically will look for potential areas that might form. And so Genesis is usually defined to be when a system becomes, say, a tropical depression. So the Hurricane Center, for example, this current tropical weather outlook said, okay, there's a 40% chance this storm is going to form in the next 48 hours, 80% chance in the next 7 days. So when this system becomes a tropical depression, it will basically be defined to have undergone genesis. So basically when you have a closed low-level circulation and winds of at least about 30 or 25 knots.
All right. I think that makes at least a little bit more sense for our audience. But our audience, very much interactively part of the conversation. Let's go to one of the next questions that we have in the queue. Again, use our hashtag system if you'd like to be featured here on this edition of Tracking the Tropics, powered by Bose Electric. KCD with this question, asking how long does it take for the Gulf waters to heat back up again from Idalia? Of course, I think our audience at this point, well aware that these high sea surface temperatures that we have seen this season, that is rocket fuel for hurricanes. But did Idalia do us any favors, you guys? Dr. Klotzbach, we'll send it over to you, and maybe Amanda, if you have any insight here on the active or the actual sea surface temperatures right now. But did Idalia help us out as far as cooling our waters down a bit?
You know, it's interesting. I got asked this question a couple of days ago, so I actually have hopefully what is considered a useful answer on this. So Idalia did cause a little bit of cooling, but that anomalous cooling, or so basically the cooler than normal water, has mostly gone away now. If you were to look at sea surface temperature anomalies, again, those differences from average, say about 10 days ago, you would see kind of a blue blob in the eastern Gulf where Idalia tracked. But now that if you look at a loop of sea surface temperatures day by day, you actually have seen most of that disappear. And so depending on how strong the storm is, it can take about 2 to as much as 3 weeks to completely kind of dissipate the cold wake from a hurricane. So if you look right now and you kind of squint, you can kind of still see maybe a little bit of an imprint from where Idalia was if you kind of squint in the eastern Gulf of Mexico. But if we were to look at the same image, say a week ago, you would have seen, you know, lighter colored yellows, maybe even a little bit of blues. But again, if you look in, say, the western Atlantic, so looking off east of the Bahamas, you do see, you know, a more notable departure from normal, and that's because you had both Franklin, but then Idalia following close on its heels, so you had a ton of mechanical mixing. So, and then Lee going over it, that cold blob is going to show up. Even if you say look at monthly sea surface temperature anomalies for September, you'll see that cold blob there, and that's kind of a classic signal of a busy month or a busy hurricane season. Is if you look at sea surface temperature anomalies even over a month or even a 3-month average, you'll start to see kind of cold wakes from all these tropical cyclones, especially when they're all taking fairly similar tracks. I mean, obviously, they came from different places, but they all kind of met in the same area. And so we'll see, we may actually have another system going through that same general region here another week or so. So after a while, those cold wakes can start to cause issues. And these hurricanes do impact each other. And I think that's something we've seen a lot of this year. In addition to causing cooler water, each of these storms, especially these larger storms, have big circulations at upper levels. So, for example, Franklin was a big, powerful hurricane. Franklin basically sheared off the first rendition of Gert. Gert made a rebirth. And then Idalia killed off the second rendition of Gert with shear. Franklin sheared off Jose. So you will see these storms sometimes kind of tear apart each other, especially if you get a lot of storms in succession like we saw, say, in late August. They will sometimes, especially if they're too close, will start to impact each other significantly. And even with Idalia and Lee, the Hurricane Center noted you could see a little bit of the shear not Idalia, Lee and Margot. You could see a little bit of the shear that was kind of plaguing Margot early in its existence was actually coming from the outflow from Lee when you get these really large storms. So in this case, Lee, if that invest were about few hundred miles farther to the west, would be completely sheared apart by Lee. But because Lee is going to move north, the shear associated with Lee will be far out of its way. So this particular system likely will be in a pretty conducive environment. Looks like it's probably still about 2, 3, maybe even 4 days away from forming, but it's looking, at least models all really seem to like it and intensify it. But hopefully we can keep it as a fish storm, but still too early to know for sure.
And the only thing I would say with that is this time of the year, it is a little easier for those water temperatures to warm back up quicker because we're still in the peak of season. We still have the high sun angle helping to warm up those waters. Now, if it was a little bit later on in the season, it would be more difficult to heat those waters back up. But as Dr. Phil, you just said, storm after storm moving over the same area, it's going to keep those waters churned up, which is a good thing.
Yeah, it dissipates the heat, which is kind of Mother Nature's cure to redistributing heat across the earth. And that's one of the reasons we have hurricanes, right? Taking that tropical heat and bringing it northward. So it's interesting to see the way Mother Nature works, Dr. Phil.
Oh, definitely. And, especially this year, we've seen a lot of things that, are highly unusual just with weather patterns in general. Obviously, with the hurricane season, the fact that we're looking at this satellite image in mid-September, this is not a normal El Nino satellite image in mid-September. We'd be lucky to have anything forming if you like hurricanes this time of year in a moderate to probably more like strong El Nino. But because the Atlantic is so warm, it's very different. Also, it's interesting, the Eastern North Pacific was quite busy. We had hope, which was a Category 5, was extremely impressive for about a day. But in general, the Eastern North Pacific's been fairly quiet the last 2-3 weeks, and that's unusual also for El Nino. Normally, the Eastern North Pacific should be going gangbusters, and it was very busy for a while, but now it's really quieted down, and there's one system they're monitoring, but it doesn't look like there's any hurricanes, at least for the next 10 days to 2 weeks in the Eastern North Pacific, which again is quite unusual
So I have a question for you.
for an El Nino year.
Oh, sorry. It sounded like your audio broke up there. I want to give our audience an idea of where your forecasts come from, your seasonal forecasts. So, you put out one early on in the year, you put out an updated one. Everybody always asks, why does Colorado State University care about tropical systems? But you guys have actually been doing this for a really long time, and you have a pretty good track record. You have access to all the same data that we do. So, where does all of that data, what goes into your seasonal forecasts?
Yeah, so Colorado State, we started doing these seasonal forecasts in 1984, and while I did mention Genesis, and I am a child of the 1980s, I was not doing seasonal forecasts in 1984, but it was founded by my mentor, Dr. Bill Gray, who was a leading hurricane researcher who discovered a lot of these kind of relationships that we use, that NOAA uses, and a lot of other groups use as well, and that is basically what we look for is effectively precursor signals. So basically what sets of climate conditions load the dice towards an above or below normal hurricane season. And basically when we do a seasonal forecast, what we're forecasting isn't actually we do forecast a number of storms, but what we're really looking at is overall, does the environment look like it's going to be more or less conducive for a busy season? So will the shear be low? Will the waters be warm? Things along those lines. Will there be enough moisture? Because basically if you have low shear, the waters are warm and you have enough moisture, you're likely to get a very busy season. And so we use a lot of historical weather and climate data to come up with these forecasts. We have historical data going back on hurricane seasons, on various weather patterns like El Nino. Some of these go back to the 19th century, but they're generally pretty reliable since the late 1970s. And we also use climate models. So you may have heard of climate models forecasting, say, like, weather 50 or 100 years from now, and say these like climate change simulations, but they also do climate models will forecast the weather 3-6 months from now. And so, you can't forecast correctly, 3 months from today, December 13th is going to be 48 degrees in Denver or something like that. But what you can do is models can do a reasonably good job of forecasting, say, a monthly average or a seasonal average of, say, okay, the shear for the next 3 months looks above normal, below normal, near normal. And so those model forecasts of things like shear also are inputted into our forecast. So with our forecast, you may hear numbers, but there are numbers, but the forecasts themselves are about 30, 40, 50 pages long. And so if you're having trouble sleeping at night, I recommend you download those. That'll definitely put you to sleep. We have every single forecast since 1984 archived in a PDF format. So there's thousands of pages of analysis of the seasons. And we also do verifications at the end of every year, because I think that's really, really important, is to verify a forecast. And while verifying forecasts that don't pan out the way you think can be painful, because obviously we want to do the best job that we can, you also learn a tremendous amount when you have those forecasts that don't pan out the way you think. And that's, every year is different. And this year, has been a challenging year to forecast, but at least as of now, the seasonal forecasts that we issued, that NOAA issued, and that a lot of other groups issued look to be tracking fairly well, and that it does look pretty likely that we are going to have an above normal hurricane season. Obviously, it remains to be seen how much above normal.
Listen, I want to say that we are all weather nerds here, so your reports don't put us to sleep. They actually keep us up at night, Dr. Phil, just so you know. And they're laughing, but it is true. So you know what? I think the natural next question is, what do we expect the rest of the season? I've noticed some signs in the MJO, and I know you want to talk about the Madden-Julian oscillation, that hint that we could be seeing activity continue. Is that right?
Yeah. And so, in addition to the seasonal forecast, which I think is what gets the most attention, we also put out 2-week forecasts. So every 2 weeks during the peak months of the season from August to October, we try to forecast how busy the next 2 weeks are going to be. And I think in some ways, hopefully these forecasts are also useful, because obviously on a seasonal level, you can't say, okay, we put out a forecast, say the 1st of August. September 17th, there's going to be a storm forming here and it's going to track and hit Florida. You can't really say anything like that. But on a 2-week forecast, you can start to highlight regions that might be of interest. And so, for example, one of the forecasts I think we did the best with was our one in mid-August. We highlighted that it looks like there could be something forming in the Western Caribbean in about 6 to 8, 10 days, and potentially heading north towards Florida and potentially being an impactful storm. And so, on a 2-week time scale, you can start to highlight that. And the reason that we do these 2-week forecasts is because you can have a busy season that has very quiet periods. For example, it's hard to remember now because it's been busy, but if you were to go back to around August 15th, everyone said, oh, the season's done and we haven't seen anything. It's quiet, it's a complete dud. And Dr. Bill Gray used to ring a bell every year on August 20th, signaling the active part of the season. The season really does ramp up about that time. And certainly this year's a prime example of that. So yeah, when it comes to the 2-week forecasts, we will be putting out a new one of those tomorrow. Obviously, we'll still have a little bit of Lee and Margot, and then likely we'll have this system coming off or that's in the eastern central tropical Atlantic right now is likely to be a hurricane. And then we are monitoring systems coming behind it. Basically, if you're looking for busy periods in the Atlantic, sinking motion over the eastern tropical Pacific is a big kind of one of the signals that you look for, because if you have sinking motion there, you tend to have rising motion in over the Atlantic and over Africa, and it also tends to really knock down your vertical wind shear on a shorter term time scale. If we look at the model forecast of shear, the next 2 weeks still look to be low. Normally, since we're now moving away from starting to get a little bit beyond that peak of the season, where the storms tend to form, you do still get systems or tropical waves, thunderstorm complexes coming off Africa, but once you get to about September 20th, 25th, the odds of them forming right off the coast of Africa go down quite a bit. The shear tends to get stronger there. Then you want to start looking farther to the west, more towards the Caribbean. You get higher latitude stuff that time of year. Usually that's not quite as impactful, but you do tend to get your powerful storms late in the season tend to form in the Caribbean. We think back to 2020, where that was basically that on steroids, where we had storm after storm after storm forming in the Caribbean late in the season. Normally in El Nino years, your late seasons are quiet because of the shear impact that you get from the El Nino. Again, it remains to be seen. Maybe it will end up being more like what we saw in 2004, where it was super busy in August and September, and then early October, nothing happened the rest of the year. And so that still kind of remains to be seen. But at least for the next 2 weeks or so, things do look pretty conducive. After that, it's just a little too far to say, how... if the tropics will finally realize, hey, I have El Nino, and start to behave like it, or if the warm Atlantic will continue to dominate in terms of the circulation. So it's too hard to know that, but 2 weeks is about as far as we can go with any skill at trying to kind of highlight these things.
And I think this will be the final question. I think we have to wrap it up soon. But do you think that the fact that the warm waters are counteracting El Nino's typical shear, are there other elements of El Nino, even in other seasons, that those warmer Atlantic temperatures might change the way we think about what to expect during El Nino?
Yeah, I mean, normally your impacts of El Nino tend to be stronger during the winter, so generally in the winter, theoretically El Nino really should drive the bus, so to speak, in terms of the atmospheric response. So normally in an El Nino year, you get an enhanced jet stream, so we tend to see more rain in places like Southern California, Texas, Florida. You tend to get, and so there's kind of these canonical responses, but other factors do play a role. The warm Atlantic could potentially play a role if it remains extremely warm. Also, the fact that the waters in the subtropical Pacific are not warm, they're cooler than normal. That's unusual for an El Nino. Maybe that could also have an impact. And we saw that even last year, right? I mean, we had La Nina last winter. Normally, La Nina tends to mean drier in California. We had record snows in California. I don't think most people in California were complaining, but there are other... El Nino is an important driver of climate variability, but there are other factors that come into play as well. And so, Dr. Gray used to always say that the ocean atmosphere functions as a single unit, and it really does. I mean, there's factors that drive these, say for hurricanes, it drives storms on a seasonal level, but also on a shorter term time scale. And there's a lot of factors even that we didn't get into today that can cause impacts on a storm or on a season. And so, yeah, I mean, we'll see what pans out with the hurricane season, and then we'll see what pans out with El Nino. But given the fact that El Nino is already basically almost at a strong threshold, the odds of El Nino for next year are quite low. And so obviously, if the Atlantic were to remain warmer than normal and you were to have neutral conditions or even La Nina conditions, we could see another busy season next year. But the winter time
Don't say that, Dr. Phil. We don't want to hear that, Dr. Phil.
I was going to say, normally the winter is when things really... So you get a lot more mid-latitude intrusions into the tropics. So the fact the Atlantic is extremely warm now doesn't mean it's going to be extremely warm in, say, December or January. Obviously, the Atlantic always cools during the winter, but, we can get rid of these warm anomalies pretty fast. Like we saw this year where water temperatures were only a little bit above normal in February, and they ramped up extremely quickly during the spring months. So you can get big changes during the winter. So there's not a lot of persistence, say, from what happens now to what's going to be, say, 9 months from now.
Dr. Phil Klotzbach joining us from Colorado State University. Dr. Phil, I want to we have some housekeeping items here before we let you go. This one for our digital team that might be able to help us out. You are, of course, a man of explanations when it comes to all things hurricane season. But I'm going to challenge you here for a moment. We're going to go lowest common denominator here. This hurricane season, the 2023 Atlantic hurricane season. You could break it down and describe it in one word. What is that word?
I mean, I hate to use the word unprecedented, but I think it is. Not in terms of like the season levels of seasonal activity. Not like we haven't seen those levels before, but the fact that we have a moderate to strong El Nino with a record warm Atlantic, we just haven't had that combination before. So in that perspective, this really is kind of uncharted territory. We've had warm Atlantics, we've had El Ninos, but not really the two in combination. Also, the fact the Atlantic is so much warmer than it has been, even in some of these other warm years. It really kind of is kind of uncharted territory in that regard.
I think we're going to have a lot of research papers on this particular season, right?
Indeed, yes.
It's going to be one that's going to be circled in the weather almanacs, no doubt. We've got one other comment in the queue that Jeff's just going to love. Jeff is, I'm just telling you, I know Jeff Baradelli, folks. He's going to love this question in the queue.
Is it about spaghetti and meatballs?
Well, you'll even better than that.
What are you
Jeff
saying about Italians?
Jeff is going to love it. But we're going to get to that in just a second. I want to ask you this, Dr. Phil. This is also on my sheet here to ask you guys about. And I'm also going to ask our meteorologists here to join in, because Dr. Phil Klotzbach, folks, is joining us really representing one of the most respected research organizations as far as Colorado State University. He is a researcher as far as he has dedicated his life to getting good information out to people, information that can help us understand the complexities of hurricane season. Our meteorologists here, their jobs are to communicate out potentially life-saving information, also to break down that research and help folks on television understand how hurricanes form and how tropical development occurs. What we have seen, Dr. Klotzbach, and to our team here, we have seen with the rise in social media, we have seen people on TikTok, people on Instagram, people on YouTube, YouTubers, who have now, in the last decade especially, we've seen this rise in them paying closer attention to hurricanes and tropical development. Dr. Phil, as somebody who is so passionate about getting good information to people and how sometimes it gets watered down on social media, what does that mean to you, and what do you make of the technological sort of evolution of how people are paying attention to hurricanes and tropical storms?
I think a lot of it is, we had social media in, say, like Hurricane Sandy, but it was still like things like Twitter really they hadn't really taken off. And so I really think for the Atlantic, 2013, 14, 15, even 16 there weren't a lot of notable storms. So 2017 came around and we had Harvey, and that got people's kind of interest going. Then we had Irma, and so Irma was this massive storm. It just was like pummeling island after island as it went across the basin, and that's, I think, what got people to realize just how people that have, I followed them for forever, but like people that don't necessarily pay attention to hurricanes, with social media, you could see footage from places like Barbuda, you could see footage from St. Martin, like places that were getting wrecked by this hurricane. And I think people didn't, before then, it was on the news, but it was kind of maybe buried a little bit, whereas now you could see like live feeds coming in from people on social media. And so I think that really did kind of get people thinking a lot more about, hurricanes and what they can do. And, since 2017, it's been generally busy hurricane seasons. We've had a lot of storms and a lot of impactful landfalls. Even last year, which was classified as a near normal season, obviously, with Ian was extremely impactful storm. This year, so far, we've had an above normal season. So far, the impacts have been, thankfully, with Idalia, where it made landfall, was a relatively sparsely populated region. And also, it got sheared right at the end a little bit. That helped kind of take a little bit of its edge off. So while it caused some damage and caused issues, we haven't seen a cataclysmic storm this year like we saw last year with Ian. Hopefully we won't the rest of the year. But I think, these storms one right after the other causing impacts to densely populated areas, is getting people's attentions more and more towards hurricanes. And it's been busy. We've had a lot of landfall. So I think that kind of helps keep people's attention. And then, there are a ton of great resources on hurricane activity. Obviously, we have TV, we have a lot of great websites now. And so you can do there's a lot more easy access to data and to visualizations now than there was, say, when I started in this business 25 years ago now. It's just a lot easier to see the data now. And also, frankly, just the forecasts and everything are just better. And the satellite imagery is better. So the storms look more impressive because we can see all these things at higher and higher resolution.
Guys, you want to hop in here? Because does it get frustrating at all when we see miscommunication occur on social media, when we're getting such great resources on social media from places like, Dr. Phil's Twitter account, for example, or Jeff, your Twitter account or X account has a lot of followers, and we're just here to communicate out this information to people. Does it get frustrating when you see it sort of warped and sort of like the game of telephone get misinterpreted on social?
Yeah, it's a double-edged sword, right? You said it, Dr. Klotzbach. The information is so readily available now. It's great, but also everybody has access to it, even the backseat meteorologists, so they can post, one outlier run that makes it seem, like the Eastern Seaboard is going to get pummeled by a Category 5 storm. Yeah. And then, also with the rise of video and things like that coming out, you have the storm chasers that are going into the eye of the storm, which again gets some good visuals sometimes, but puts them in the harm's way. But even though, they're doing that to get the views. So it's good, it's bad. I do think that it makes our lives easier in terms of that readily available information. Sure. But also makes our lives harder when, the backseat meteorologist posts things that, really shouldn't be shared because they're just not credible.
Right. It's clickbait, and it does bother us to some degree. And I have gotten a barrage of emails from people in New York saying, this is coming to New York. And I'm thinking, where did they get that from? Sure enough, it's, I would say, irresponsible media. And also it is a lot of people that are posting clickbait on social media where they're seeing this. Of course, this storm never looked like really that it was going to New York. There may have been one run or two runs of a model. It was posted by somebody, some cowboy on social media, and it took off. And, it does change our job. We have to address, and that's one thing for sure. We have to address stuff way before we used to, just to try to head off the irresponsible posts that we see on social media.
Because people will post those pictures, and even in the description, if they write, this is not necessarily going to happen.
Or this is not a forecast.
People don't always read the descriptions, and they take the picture and run with it. So it's tough.
I'd like to also, wait. Before I give Dr. Phil, I'm going to give you a little sort of a last word here to end out our stream. If there's anything else that you want to share or communicate out, or if there's anything you want to point out to our audience, but I wanted to get to this comment that Jeff is going to love, and it comes in from Carmen on the WFLA Facebook page, and it's, why do storms never make a direct hit to the Tampa area? It's been over 100 years. Jeff, I think you have something to share on this particular topic with Dr. Phil, don't you?
Yes. So, Dr. Phil, we did a partnership with Columbia University and the Lamont School. You probably know Dr. Susanna Camargo and her team, Dr. Lee. And what they did was they used the CHAS model for us, and we simulated over 1 million hurricanes. And I'm not going to reveal on this program what the results were, because tomorrow the story is going to air, and we're going to also push the story out on social media as well. We did a specific study on the Tampa Bay area, and to figure out whether this essentially lack of major hurricanes over the past 100 years is just luck, or if that is our normal climate, what we would have expected to see over the past 100 years. And so we simulated about 1.9 million runs on 1.9 million storms on the CHAS statistical model, Dr. Phil. So I'm really excited about this, but I can only tease everyone. I can't give the information because we're going to release it tomorrow.
I would like to point out with Tampa as well that I know that one of the kind of theories is that there's this Indian grave.
Yeah, that's right.
I knew that.
Ground that protects the city. However, if you look historically, so the National Hurricane Center's hurricane track data set goes back to 1851. But 3 years prior to that, in 1848, Tampa actually had 2 landfalling hurricanes that were 2 of the 3 highest storm surge levels in Tampa. And I can guarantee you that burial ground goes back prior to 1848.
It was. It was.
It's one of these things where, I think it's a little bit hard to hit Tampa just given the overall kind of steering flow that steers the storms, but there's a lot of luck involved too. I mean, there's no real magical reason why Idalia went into Cedar Key and didn't make landfall a little bit farther to the south. So, at some point, hopefully not in our lifetimes, at some point Tampa will get hit again, but hopefully the luck will continue. But definitely, there's a lot of low lying property in the Tampa area. And, obviously some point the negative surge that we saw in Ian and the negative surge that we saw in Irma, at some point that's not going to be a negative surge. So hopefully, people can, stay prepared, because at some point the storm will actually come to Tampa.
Mm-hmm. Let's all knock on this wood.
Yes.
That's what I've been doing. This is definitely not wood, but whatever. Maybe it's particle board. Maybe that counts.
I don't know.
Really sure.
But Dr. Phil's joining us from Colorado, so I think he's in the clear there. Dr. Klotzbach, very respectful of your time. The time is now approximately 1:30 Eastern, but I wanted to give you the final word. Is there anything that you wanted to share with our viewers, our audience, our listeners before you go on this edition of Tracking the Tropics? Thanks so much for joining us.
Yeah, thanks so much. Thanks so much again for having me on the program. In terms of products coming out from Colorado State, we'll be putting out a 2-week forecast tomorrow. You can get that on our website, or you can get it. I'll post a link to it on Twitter/X. It's early, or probably around 11 o'clock Eastern tomorrow. And then we will put out another couple of 2-week forecasts in late September and then in mid-October, and then we'll put out a verification of all of the forecasts in the latter part of November. But thanks so much for having me, and best of luck.
Yeah, it was great to have a weather geek out session this Wednesday. Again, Tracking the Tropics is live every Wednesday, 12:30 Eastern, 11:30 Central, over the course of hurricane season. We're right at the peak of hurricane season, folks, so don't go anywhere, because, of course, we're going to continue to track Lee, Margot, the other invests that are, of course, forming in the Atlantic. I'd like to thank our great Max Defender 8 weather team here at WFLA. Meteorologists, I'll go left to right, Amanda Holly, Chief Meteorologist Jeff Baradelli, meteorologist Rebecca Barry, and of course, Dr. Phil Klotzbach joining us from Colorado State University. You can find all of our hurricane and tropical resources on WFLA.com. You can also find it on trackingthetropics.tv. We'll be back next Wednesday or sooner if we need to let you know about a particular storm, but that'll do it from Tampa, Florida on this edition of Tracking the Tropics. Have a good one, everybody. Take care.
Find Tracking the Tropics on these platforms. And for storm updates, the latest models, and helpful resources, visit trackingthetropics.tv.